skywave propagation. The skywave propagation plays a crucial role for transmitting signals to long distance communication using high frequency bands. The skywave propagation mainly used for long distance communication. Unlike line of sight, the skywave propagation interacts with the ionosphere by the mechanism reflection and refraction. By using this mechanism, the skywave propagation is used for long distance communication. So in this case study video, we are going to see about how this mechanism works and how it is important for using long distance communication.
So in the mode of communication, we would mainly talk about the transmission of signals from one place to another. It can be any other type, such as in ground and sky. Basically, in skywave propagation, the motions of the waves are travel along the surface of the Earth and it interacts with the ionosphere layer. So basically, the two physical phenomena such as refraction and refraction mainly plays a major role to make the wave come into the Earth from hitting back into it. And the next part is about the line of sight wave transmission. The skywave propagation plays a major role in it. So this case study is based on the propagation of waves in the sky side will be efficient to travel the wave from short distance to long distance. So the communication will not interrupt in any sense.
So coming to the basic concept of skywave propagation. First, the skywave propagation is composed by the radio wave transmitting from the antenna to the uppermost layer of the ionosphere. Ionosphere are nothing but the uppermost layer of the atmosphere, which consists of large particles which are created by the solar radiation. So for in the sending of the radio waves, it was actually was to travel to the sky, but with some of frequency it went to the radio wave and reflected and redirected to the Earth surface. So this type of phenomenon it cancels the most of the long range communication. So it was majorly essential for the aviation communication and international broadcasting. So this plays a major role in skywave propagation.
The refraction is the major mechanism used in the skywave propagation, which is used to send the radio waves to the ionosphere frequency and getting it bounce back to the Earth's normal surface. By considering this ionosphere surface, the normal radio frequency is sharply bounced back. But considering this ionosphere, the signal wave is stretched and smoothly bounced back towards the Earth communication. And then moving to the next, the lightweight signal is smoothly bended towards the Earth, and when the I waves is less, and sometimes it may not reflect back to the Earth. This consists of the incidence, angle of incidence, the refraction, and the frequency parts.
Coming to the refraction, this is reflection part. Although we are often describing this as refraction, but the process happens in the ionosphere. It's actually called as refraction. True reflection is the process which we bounce back to the like a mirror. But in the ionosphere, the waves are often refracted, while it will be continuously bending until it reaches the Earth. So this is called as the refraction. But in the in the communication simple in terms, we are mentioning it as reflection. So we need to understand what is the difference between refraction and the reflection to maintain the very good outputs.
A practical example of skywave propagation can be seen in shortwave radio broadcasting. International radio station uses skywave to transmit signal, and for instance,
It transmits the signals across the continent.
For instance, one transmitter in continent transmit the signal in night. In night time, the signal transit further with less absorption. This demonstrates how refraction and reflection transmit globally, enable global communication without satellites.
So in nighttime, the ionosphere layer is stable, so we can send in for communication purposes. So
With less absorption.
for go 1000 kilometers also we can transmit a signal. So in conclusion, the skywave propagation behavior influences for by choosing correct frequency. So the engineers must choose the frequency correctly. Then only we can transmit the signal for long distance communication by using reflection and refraction by hitting the ionosphere. By choosing the maximum usable frequency, we can transmit the signal to long distance communication. we choose the frequency incorrectly, then we can't send the signal